Okay, so our next speaker is Dr. Nikolai Kinaev, and Dr. Nikolai Kinaev is the lead the hydrogen energy systems future science platform at CSIRO Australia. You know, CSIRO is a Commonwealth Scientific and Industrial Research Organization, our premier state-owned, state-funded research organization. So all the big thing is coming from there. And for your information, many of you know that Wi-Fi that we are using at the moment anywhere in the world, without Wi-Fi, we are absolutely grounded. This Wi-Fi is the innovation and discovery of CSIRO. Okay, so we feel very proud of it. And so we'll come back to our Dr. Nikolai Kinaev. Prior to this position, he worked in the industry analyst and information gathering and analysis of a specialist with diverse professional background across Europe, USA, and Australia. Nikolai has been recognized by the professional community for his ability to identify emerging trends early, both globally and regionally. He is an expert in various industry-related fields with a deep understanding of techno-economical issues, actual project cost, technology deployment timelines. With 30 years of experience in research and industry, Nikolai possesses a unique understanding of research and industry activities and approaches in various areas. I also say Professor Nikolai is very actively collaborating with our group, and with his assistants, we have a PhD project going on particularly in new energy, the hydrogen energy. And we'll come back to that one later after our first session. So with this note, I invite Dr. Nikolai Kinaev to present his topic is hydrogen energy technology and their future perspective. Dr. Nikolai will be doing through online. Unfortunately, he cannot join us because of his little health issue. And so, Dr. Nikolai, please, now floor is to you.
Okay, thank you very much for a very kind introduction. Yep, I can see that it's actually start sharing. My topic today is hydrogen energy technologies and their future perspective, where I'll try to give an overview of what we're doing in CSIRO and hydrogen space and why. And CSIRO is an Australian national science agency. Firstly, I would like to begin by acknowledging the traditional owners of the land that we're meeting on today, and obviously I'm it Turrbal people area, and you in Melbourne has different tribes, and pay my respect to the elders past, present, and emerging. And it's quite symbolic that we're actually talking and giving acknowledgement, but deeds, what we're doing is more important than words. And what we're working on, what we're doing is working towards sustainability and returning land to its and water to its pristine conditions. So I think this is the biggest acknowledgement that we have, rather than words, that what we're actually doing is working towards sustainability. A couple of words about CSIRO. It's Australian National Science Agency. It's multidisciplinary science and technology organization, have 57 sites. Sorry, a little bit updated data. We have now more than 6,000 staff and about more than 5 billion a year value delivered to Australian economy. And as you can see, we have number of various business units and areas that we're working on. I'm presenting the CSIRO Energy, which consists of 3 streams: energy resources, energy technologies, and energy systems. And the most of my work will be concentrated, I would say, around the energy technologies and energy resources in this particular topic. So why hydrogen? Or there's so many phases of hydrogen. If we look at various sector coupling and the role of hydrogen, you can see that it acts as a for both power and the industry input. The use of hydrogen is enormous, but then comes the question, is hydrogen actually one of the things you have to remember? Hydrogen is not a fuel. I would say that it's not a fuel, with one exception I'll talk about later, and this is the natural hydrogen, the hydrogen that goes from underground. However, hydrogen is critical as an energy storage and as an industry feedstock. So let's look at what we're doing in hydrogen space and why in this sense. Look at the hydrogen value chain. We've got the production, we've got the distribution and storage, then it goes for domestic application in various forms. It could be hydrogen, it could be ammonia, it could be methanol, it could be green methane, or it can go through further distribution and transport to the export market, and it's all sitting on the on the basis of techno-economics, understanding the emissions, community acceptance, and provenance. So what are the areas we're concentrating our research on? Firstly is the production, and we're looking at production not from the fossil fuel like steam, methane reforming, or coal to hydrogen. It's quite mature areas and doesn't need much of a research at this stage. So we're concentrating on some of the electrolysis things, biomass pathways, and also what is important on geogenic hydrogen, or so-called nitrogen or golden hydrogen, or microbial pathways. Then we're looking at the ways how we're distributing and handling hydrogen in industrial applications and how we actually use it for mobility, particularly for marine environment, and also how we use it for power generation. And of course, we're working on techno-economics and environmental things, and Dr. Noshat Haq will have an ability to make you familiar with the wonderful work he and his group is doing in this area, working on community acceptance and the other cross-cutting areas. So how the work on hydrogen is organized in CSIRO? We've got, let's look at this from the technology readiness level. The proof of concept thing, the early studies done within the internally funded Hydrogen Energy Systems Future Science platform that I'm running off. And then it goes progressing further to CSIRO business units when it typically have the industry or government partners, and going for higher TRL for commercialization and demonstration, so the hydrogen industry mission. So sometimes you heard hydrogen FSP, sometimes you heard hydrogen industry mission in regards to CSIRO. We're doing the same thing, just on a different technology readiness level. Let's look at what we're doing in terms of the Future Science platform. It's essentially the program that, as I said, internally funded, is focused on a high-risk, high-impact profile, and it's working across the whole hydrogen value chain. And here are the major, here is what example of our project portfolio. We're looking at novel hydrogen production and the natural hydrogen and photocatalytic synthesis of hydrogen when we're combining the solar battery and the electrolyzer in a single unit, and it's not like having a solar battery sitting on top of electrolyzer. It's essentially within the same unit you've got simultaneously local dipoles of electrical dipoles that work as an electrolyzer and produce hydrogen. We're also working on the new things in electrolysis and understanding how to progress electrolysis further. We're also looking at ammonia production. And here we have to be uh, very serious in terms of Haber-Bosch process, which is ammonia produced now, is a masterpiece of engineering, and we're not going to replace it for a large scale. The only problem with Haber-Bosch process, it's essentially the large scale process, which can't be downsized. But in future world, we're living in the situation when we have both centralized and decentralized production of hydrogen and ammonia. So we're looking for distributed for small to medium scale ammonia production that are comparable in its efficiency with the Haber-Bosch process and working at lower scale. We're looking at membrane systems actually to work for both ammonia cracking and ammonia synthesis, and we're looking at the opportunities for biological synthesis. With the hydrogen storage, we're looking at things on geological storage, hydrogen liquefaction, how to convert ammonia efficiently back to hydrogen. And hydrogen handling, of course, we have to look at hydrate compression, how we can actually have the solid state compression of hydrogen, which is more efficient than existing one. We need to look at hydrogen embrittlement, and we need to look how we handle materials with that actually work with hydrogen. Those bits are connected together. And of course, we need to look at hydrogen use and methanol production, hydrogen burners, using ammonia reduction for or ammonia decomposition. And don't forget that we have to look at environmental impacts, techno-economic evaluation. We have to make sure that what we're doing is socially accepted and meet the regulatory requirements. This gives you some highlights of what we achieved so far with the capabilities development. We develop quite a number of expertise within CSIRO, and we developed the novel approach in techno-economic evaluation framework, which is actively used now. And for those things, I'm happy to give all these credits to Norshat and his group. We're developing a novel approach to social science methodology. We've got a number of experimental capabilities like spray pyrolysis, which belongs to the photocatalytic production of hydrogen, but it goes more than this because it allows us to do the modification of a surface in a scalable way. So this is what we're calling the technology platform, and we have huge expertise in natural geogenic hydrogen exploration, where in hydrogen storage we're developing the fantastic state-of-the-art capabilities for geomechanical properties to you look at hydrogen embrittlement and the solid state compressors. And in hydrogen utilization, there's quite a number of real interesting work on fractal burners as well as on photocatalytic conversion of CO2 to methanol and green methane. And also we're doing the creation of new science with the new concepts like using advancements to understand social science is exceptionally important, and it's much broader than just hydrogen, but with using hydrogen as a springboard to get this new research happening across the whole thing. I can go through this list for ages, and I know that I have a very limited time. I'll also ask the chair to let me know when there's actually when they want me to stop. Give me about 5-minute warning when they want me to stop, please. So for those who are interested in getting more information on those projects, please feel free to reach out and contact me. I'll be happy to chat with you and say. But now, why we're using these directions? How we're making the difference? What are the criteria to choose the right projects? And there's a number of criteria. First one is relevance. Work has to address the real industry needs. And even if we're talking about what we call Horizon 3 low TRL levels, it's still, you still can do the fundamental science, but trying to understand real industry needs. And for this, you need to have constant communication with an industry. With the new science, the topics that we're working on has to be related to the largest knowledge gaps. It has to be trying to get the biggest, identify the biggest knowledge gaps and try to fill them. Impact, we're looking at step changes, decreasing the number of process steps or new use cases, or doing the significant system performance improvement. For example, if you are talking about saltwater electrolysis, if you start thinking, okay, we'll do the saltwater electrolysis because it take off desalination and will reduce the cost of hydrogen. Sorry, guys, it's not the right reason, because cost of desalination adds 2 cents to the cost per kilogram of hydrogen, which is a statistical bleep. If you're going to do desalination, saltwater electrolysis, it has to be not the cost reasons for this. And also, when we're looking at the projects, the bonus is it's broader than hydrogen and can be applicable in the other sectors or helping to establish Australian hydrogen technology supply industry. So those are the criteria that Hydrogen FSP is choosing their project portfolio. Couple of words about hydrogen industry mission. What are they doing? It's essentially the activities goes into Hydrogen Knowledge Center, into helping to develop strategy and national partnership. It's the demonstration projects and some work on enabling science and technology in demonstration phase. One of the things that I'm strongly advise you to use, there are 2 important things on the portal. There's high resources, which has the database of, it's a live database of all the industry projects in Australia, and they have all the information about this. And also very important, high research, which is the Hydrogen Research and Development portal. And please log your, it's not just for CSIRO, it's all the researchers are encouraged working in hydrogen, are encouraged to reach out to the high research portal and log their projects there. And by the way, this is where industry is actively looking at this portal and understand what's happening in the research. So if you want to promote your research in hydrogen, that is a good way to go there. Also, we're doing a number of hydrogen hydrogen industry analysis and demonstration facilities. And in Clayton, we have a hydrogen refueling facility, and also it's sitting next to the cryogenic hydrogen research facilities. And those provides a real good and serious platform and allows to test some of the concept directly. And also, as Professor Alan Feroz knows, that we have also the CHESS Center in which is the Center for Hydrogen Energy Systems, that allows to do quite an interesting and novel research in the hydrogen systems. And also, we're together with the Hydrogen FSP, we're working on understanding the public perception of hydrogen. Now, a couple of things about what we're doing in terms of the hydrogen production, how we ensure that we have supply of hydrogen. There are a number of works in hydrogen electrolysis technologies, and they're already commercializing. We have two spin-off companies in Duo on PEM electrolysis and also heading on solid oxide electrolysis technologies, and they are quite successful in commercialization and working with hydrogen. We have a larger projects working on demonstration on distributed ammonia production, and this is the important thing because it allows also to secure the Australian fertilizer supply. By the way, you probably, for those who are not aware, we are currently have importing 75% of the fertilizers that we're using. So we need to look at how we can produce nitrogen fertilizers for Australian needs on a more sustainable way. We're working on metal membrane ammonia to hydrogen technology, which is successfully working on commercializing with our industry partners. There's a catalytic static mixer technology, which again is what I'm calling as a platform technology, because with that one, we're using, this is an example, we're using it for liquid organic hydrogen carrier processing, and we already have a commercial project running on that one. However, it could be applied to other hydrogen and non-hydrogen related processes, because catalytic static mixer allows you to modify a lot of gas liquid reactions and get away from the packed bed reactor with improving both thermal and mass transfer properties of the reactor. We're working a lot on natural hydrogen, and the first discovery of field measurement of natural hydrogen SEEPs in Australia. And when we started this project, it was several years ago, it was a hypothesis, and now there's several commercial companies running for the natural hydrogen exploration, and we're giving them a trusted advice in this area. But we're not just working in the green hydrogen in traditional sense. We're looking on how we can actually provide hydrogen from biomass or waste gasification based on the enormous experience that we have in our biomass and waste gasification and having our own facilities there. So this is another area that we're actively working on. In hydrogen utilization side, iron and steel is the first thing that looks very important, and there's a lot of activities happening, but we're in CSIRO now concentrating on not just those ones, but looking on how we can generally decarbonize the pellet production, and also we're looking how we can actually produce use green ammonia to work. In storage and distribution options, looking at ammonia, firstly looking at ammonia as a hydrogen carrier. And it's not just cracking ammonia to hydrogen, but we see, can we use it directly in fuel cells? Can we do the distributed production of ammonia for the fertilizers? There is a work on direct use of modified diesel engines in of ammonia. Again, as I said, we're working on a number of new areas of ammonia synthesis technology, and with ammonia engines, this is where we're looking on low-speed marine engines who are ideally suited for ammonia thing. And another huge market is power generation. And again, the advantage of those approach that we can essentially use utilize the existing diesel fleet by retrofitting it rather than going through the whole replacement. Last but not least, hydrogen supports the utilization bit in CCUS. And yes, still the best way to deal with large-scale CO2 sequestration is geological one. But there's a number of point sources of CO2 when we don't have enough amount of CO2 that is validating the geological sequestration. And here comes our transformation of CO2 to methanol or methane or formic acid that can be used as a chemical feedstock, so rather than be buried into the ground. So this, I hope, gives you some overview. What's the next? There's still plenty of work to be done. We need to look at the cost reductions, new technologies, reducing process steps, cheaper storage. We have to look at what are the other applications, modern power to X. We have to look at where else we can use hydrogen. We have to look at new technologies, new pathways. And important thing, if you are talking to the industry and when we're talking demonstration, it's de-risking. It's about how you de-risk the hydrogen applications in the industry, in hydrogen for decarbonization in the industry. And now some thoughts about hydrogen. And yes, hydrogen is a very fashionable world and something that now, like, virtually it seems as another silver bullet. Sorry, guys, I have bad news to you. There's no such thing as a silver bullet, but there's a silver buckshot. And hydrogen is just part of the solution. When we're talking about hydrogen as a heat source, don't forget concentrated solar thermal or bioenergy. In CO2 emissions, CO2 capture, utilization, and storage. And electrification is you can use electricity to produce hydrogen, or you can use electricity to run the process, or you can use both. And this is where you have to find where is the right balance, for example, to which degree it's economically feasible to feed with electricity, and when you need extra heat, then you probably generate it by burning hydrogen. So the number of things, the fact that I'm probably sounds strange from the hydrogen guy, but the fact that you can produce hydrogen doesn't mean that you should. You have to be very mindful why we're using hydrogen and what is the real use and what are the alternatives for this. I would like to acknowledge the whole CSIRO team, as well as the fantastic people that are working on hydrogen energy systems portfolio projects. Thank you very much, and I'm happy to take the answers. Sorry if I took more time than I supposed to. Sorry, can't hear you. Yep.
All right, I think he can hear us. So we have to give the clap again because he did not hear again. Okay. All right. So, all right. Yes. So yes. So okay. So on behalf of Dr. Nikolai, we give this certificate to Dr. Naushad Haq, his colleague, and later on he will pass it to Dr. Nikolai when he'll be in Melbourne or in Brisbane. Thank you.
Thank you.